So welcome students, myself Mahendra Saini, faculty from Civil Engineering Department. I would like to teach you today about the subject Wind and Seismic Analysis of BTech 6th semester. Okay, so in this semester, in this subject, we are going to discuss today important topic of earthquake load calculation, which lies under chapter 5. Okay, so this earthquake load calculation is given in IS 1893 2002 part 1st. There are several versions of this code, but specified in this code 1893/2002 part 1st. Okay, so calculate seismic weight first, denoted by capital W. And what is seismic weight? Seismic weight, it is the combination of two loads, dead load and live loads. Okay, so after then calculate horizontal seismic coefficient. So after then calculate horizontal seismic coefficient, represented by capital A N. Okay, and what is the formula which is given in page number 14? So AN equal to ZI upon 2R capital R dot SA upon G. Okay, so this is a numerical, or we can say this is these are the design steps of solve a numerical. If you are able to understand this video or this numerical design steps, then you need not to calculate any numerical of this subject, of this particular part, earthquake load calculation. Okay, and even if you write the only design steps in the exam, then you can easily get 10 marks out of 16. Okay, so but one thing, something you have to add in this design steps, means put the numerical value given in the question, and then all those design steps which we are today discussing, you can write in the exam directly. Okay, so definitely you can achieve good marks. Okay, so Z equal to zone factor, and zone factor it is given in page number 16, table number 2, or okay, page number 16 or page number 35. Okay, there are two availability at different pages. Capital I, it is the importance factor given in page number 18. Okay, capital R, response factor, it is given in page number 23. SA upon G, it is called average response acceleration coefficient, which is also given in on page number 16. So SA upon G depend on the capital T, that is natural period of vibration when earthquake takes place. Then how much time earth is shaking, so it is denoted by capital T, natural period of vibration. Okay, calculate natural period of vibration in that way, in this way, capital T equal to 0.09 h, small h, upon VD. Okay, so page number it is given on page number 24, where small h is the building height, which is which will be given in the question. Okay, small d is the dimension of building, it is also given in question. Sorry, capital T equal to 0.09 h divided by square root of d. not v here, square root of d. Okay, and it is given in page number 24. So small d, what is the small d? Dimension of building in x or y direction. It is provided by the in the question by the university. Okay, here important note is also given that value of capital T means natural period of vibration. Put in SI upon G formula and get SI upon G value, and putting values Z, all Z, I, R and SI upon G in step second and find AH. Okay. So step 4. In step 4, design seismic base shear will be calculated, denoted by capital V into B, capital VB. Okay, and capital VB means design seismic base shear is equal to the W into AH. It is given in this formula is given on page number 24. So step 5 what it say? So in the step 5, distribution of design force means represented by capital QI, and QI will be calculated as QI equal to VB multiplied by WI square upon summation of WI square. Okay, so it is given, this formula is given in page number 24. What is WI here? WI is the seismic weight of the floor I. Suppose I, if we are talking about first floor, and I is putting, I will be 1. If we are talking about second floor, then it will be 2. So HI, what is HI? HI is the height of the floor I, such as 1, 2 or 3 and so on. Okay, measured from base. Okay, it is remarkable in the mind that it is measured from base. Important note is here, calculate for every story. Okay, capital Q should be calculated for every story of building, and after then use of the following table. So what this table says? It says that a format is given here. In first story number, you can easily write this like 4, 3, 2, 1 in decreasing order. Top floor should be kept in first priority, and after then WI, HI, different columns are here, and WI, HI square, the product of these two as per formula. Okay, and the formula of WI, HI square upon summation of WI, HI square in the next column, and VB base shear and QI for x and y direction both should be calculated. Okay, from here in this WI, HI square we can calculate after summation of these all the story WI, HI square and get summation of WI, HI square, after then put in this formula. Okay, so these are the steps involving earthquake load calculation, which are very easy and easy to understand. I hope you will able to understand this video very good manner. Okay, so there is nothing in this question, only simply we have to calculate WI is given in the question, HI is given in the question, WHI square we can easily calculate, VB base shear we can easily calculate by this formula VB WAH, and what is how we can calculate the AH? So AH will be calculated like this, ZI upon 2R, SI upon G. Okay, all those unknowns are given in the code as well as in the question. So there is no any tension to solve this type of problems. Okay, we will understand in next lecture very deeply, and try to understand how to you calculate by using any numerical value. Thank you. So keep watching. Thanks.